All right, hello everyone. Welcome to ECS 179 Gameplay Programming. Today we are going to be answering some questions about exercise 2 and about peer review. Then we're going to go over an exercise on LERP. There were enough questions about linear interpolation and how it works in Unity that I'm bringing out a little project to show it off. Then we're going to discuss, well, we may start off with this, some changes to the syllabus and schedule. I've reconfigured things to give you some more information for the next exercise in a more timely manner, plus a participation opportunity. And then we will actually finally cash out playing some games and talking about the game exercises. We kind of ran out of time the last few class meetings, and now we have some time. All right, so I'd like for you to prepare any questions that you have about exercise 2, about peer review, about exercise 3, while I go over the changes in the schedule. All right, so here is our schedule for the class. We went through gameplay mechanics, game events, the observer pattern, we went through mechanics, rules, and gameplay systems. Got a little ahead of ourselves last week. So what we're going to do is actually push off component systems. We're going to swap component systems in the factory pattern in the schedule. Because exercise 4 is about the factory pattern, I want to give you a chance to play with it and have a participation assignment that's optional. I can get you participation codes. Do while you're thinking about implementing or finishing the factory pattern for exercise 4. All right, a little bit of synergistic classroom activity to close the loop and other corporate buzzwords. Which means that the factory pattern readings, there wasn't a chapter on the factory pattern in the gameplay programming design patterns book, the gameplay design patterns book, or game design patterns book by Nystrom. So the readings for that are inside of the assignment. They're part of the assignment description. So I'll be giving you those, and we'll be going forward. I'll release that a little early. There's some little cleanup I need to do to it, which is why it isn't linked, but we will get you there. Exercise 3, then its various due dates, and exercise 2's peer review, and the due dates are listed in Canvas now, so you can go check those out. So far, it looks like people have been adapting quite well to the peer review project, the peer review exercises. I'm looking forward to seeing what you come up with those. We'll start grading those right away with a goal of having your grades given back to you a week after the peer reviews are due. So exercise 1 full grades. If everything goes as planned, we'll be back to you next Tuesday. All right. Questions? Exercise 2, exercise 3, peer review. We have a few more empty seats today. Must be nice out. Yes.
For the exercise 2 peer review, are we reviewing that strictly with the requirements, or should we refer more to like the examples we showed us in class? Because I feel like some of the requirements were kind of like vague. I refer to your examples a lot more.
Yeah, there's a space of possible good solutions, right? And so when you review those, you want to contextualize how the review is with respect to the solution. So there's more you can potentially write about. There's more analysis you can do. You can situate their specific solution with respect to the solution space. For instance, the auto scroller, you had some options there. You could simply restrain the player within the box and auto scroll, right? But we left a little underspecified on what effect the auto scrolling has on the player's position. The example that I actually showed you 2 examples in class. One where the auto scroller moved the player along with auto scroll speed, which is the default configuration. One where the player was not moved along by auto scroller, but instead was caught by the boundaries. So the player was not moved by the auto scrolling camera unless the player was on, let's say, the left edge when the box was moving left, right? There's also another variant where you could potentially push the box faster than the auto scroll speed if you press it on the right edge, or if you were, say, in the vein of R-Type, one of the seminal shoot 'em ups, you could actually move the box up and down if the auto scrolling was going to the right. So there was vertical play within a horizontally shifting level. All of these are very valid auto scroller shmup control schemes, or camera control schemes. As long as you have something reasonable and you have something that isn't broken, you will probably do well in the assignment. So it's up to the reviewer to contextualize what you actually have implemented and how it works with respect to the very basic assignment description that I have for you. Does it auto scroll? Does it have some sort of box boundary play? Those are what we're looking for, right? Yes.
If I were to, this is more of a generalized question, in exercise 2,
Uh-huh.
if I were to need more, in like a future game, if I were to need more access to the functions of said class, would I pass it as, pass it as a class object instead of a game object? For instance, like target, being passed as a game object. If I needed more access to that class's functions, would I pass it just as the class object, as like ease of use?
Okay, so this is where Unity is a little interesting, right? Because when you pass a game object, you can use get component on the game object to get access to any of its components, including entire scripts. So I'm not sure what extra power you would need past that. In this case, you want to look very critically at your design and the layout of your components and the layout of your objects. Here, it's where you start getting domain specific. How did you lay out your game? Where are the responsibilities? Where is the information? Where is that interesting set of functions and procedures spread throughout your code? If you are constantly needing to get entire chunks of scripts from other objects and it's becoming an impediment and difficult, then perhaps you have your division of responsibilities put in the wrong places. Perhaps you need to, if you are constantly going back to a global area or fetching things from far other memory spaces and other objects, perhaps you need a set of managers or brokers that help you manage that space that have connections to all those objects. And so you get your broker class. This is one of the few places where the singleton design pattern is beneficial. It is managing globals, right? So this is where the individual engineering of a game, the personalized engineering of a game, gets difficult, right? So we have a very clean breakdown of player versus camera, right? And those two should talk to each other and pass information between each other. This is why we have some publicly accessible methods and accessors to help that communication back and forth. And that's why we can simply pass a game object and we know there's a player controller and we know there's a camera, right? That makes our communication quite easy and we don't need a larger broker because of that. But let's say you are working on your own version of SimCity. And there are lots of objects with lots of information all over the place, and they constantly talk to each other because things work in networks and relationships and neighborhoods, and those have a stronger global effect on, let's say, the tax money you're bringing in to be able to spend on further buildings and zoning, airports, zoos, etc. Well, there, everything is a little more collective. So you should probably use some higher level collection that knows about everything, and you can easily look over many objects at once without doing a bunch of memory crawling or a bunch of fetching of components from various objects. You'd probably want something like, perhaps if you had a building class, perhaps you would make a static constructor and have a static collection where every time you make a building, you would add it to that static collection, right? So now you could have something that has a little more memory locality. You could have something that is maybe even hashed for fast indexing and fast lookups to make your code faster and to make it easy to access and access it in a uniform, predictable, debuggable way. Right? So this is where, when your game gets more complicated like a SimCity, you would want to think much more deeply about your software engineering and your structure. So I gave you a very long answer to this, but I think it's a more complete, useful answer to you in the future than answering simply just for exercise 2. Did that help?
Yes, so that depends.
Yeah, so it depends. Yeah, it's a fancy depends. it really, game engineering is tough. There's this idea of the Photoshop of design, right? Where you have all these like filters that work very easily over small things, little tools that can work on anything. Well, if you think about how Photoshop works, basically you have this common space that everything can talk to, which is a grid of pixels, which is a large pixel array. We don't have that in games, right? The knowledge space and the information space in games varies in structure and dependencies so much that there is there's very few places where there's a one-size-fits-all solution. And usually we handle that with genre conventions. So our solutions and our game systems and our implementations tend to be genre specific, right? And there you get a little bit more generality and a little bit more of abstraction that you can use across games. But a platformer set of conventions and code just is almost meaningless when you're looking at real-time strategy games. And so there's not a lot of correspondence between the two, which is what makes this difficult. It's complex, it's ludic. All right, any other questions? Yes.
If I change like the object hierarchy of my project because I added like a little bonus feature, is that okay?
You added a little what?
Like a little bonus feature.
A bonus feature?
Yeah.
Yeah, as long as you preserve the function of the stages.
Okay.
You may want to add some documentation of what you changed and why at the top of your README.
Right.
That's our conventional place. If you see something that's funky, look at the top of the README and see if there's a reason for it. We like you to tinker. We like you to play in this class, right?
And then if I didn't use LERP in stages 3 and 4, but like it still functions the way I want it to.
Yeah, LERP was one option, one tool for you to have the physics smoothing style camera. Yeah. And LERP is kind of an awkward tool for the situation, but it's also one of the standard tools used for this type of thing. Literally, like we use linear interpolations a lot in games. A lot of times we use it as a hammer when what you need is a screwdriver. So that anything that has values that change over time, we tend to use linear interpolation and curves. And this is camera directions changing over time with relationship to player controlling. Although we'll talk about it today when we go through the LERP example of why. But I'm glad you found a solution that didn't use LERP. My favorite solutions to that do not use LERP. Questions? Exercise 2? Exercise 3? Oh, 1 then 2?
Yeah. For like the peer reviews, there's like the 2 different sections in terms of frame style guide.
Uh-huh.
With the one focusing on netcode style guide and the other one focusing on Unity style guide. If I'm understanding it correctly how that works. So I feel like there's like first of all, there's like a certain like a lot of like the style of charts that Unity does use C# as its programming language. So if there, but like some infractions are really something that's really Unity and Style specific. To I guess like I was just having a hard time deciding like what goes where in terms of some cases.
Yeah.
And if like maybe if
That's
like,
fair.
If there's something that like breaks both, do I want to split up how I mention it or put it in like one that is like seem like it's more like a C# thing rather than Unity.
Yeah, so usually when we have Unity conventions, when it's in the Unity style guide, that will take precedence over the more general C# style guide. Now, this is really a symptom of something that we need to clean up for the class structure, which is the actual style guide itself. We've been like coalescing that into something that is canonical for the class. So we're being a little permissive on it right now because, frankly, we're behind in that task. The rule that you typically use when dealing with style guides with a code base is you want to follow the conventions in that code base. So if you look at exercise 2, exercise 3, they follow predominantly the Unity conventions, but there are cases like when there are classes for member and function declarations where where Unity does not provide a strong set of exemplars, a strong rule, then we fall back to the .NET rules, which is why you'll see capitalized member functions and capitalized public members, but lowercase private members. And then you'll see Pascal case in function naming and things like that. But you'll see camel case in local variables and arguments. So that's where you adapt to the local code base.
Also, whether before we talk about the scale guide, like just in general, do you get a good job on like the different codes, or if since you just said one stage is perfect, and then explain why.
Yeah.
Is that mostly just tailored towards is it actually functional, or could I potentially mention a few things from a style guide perspective and then elaborate later?
Yeah, you could definitely mention things about style and then elaborate later. But those are mostly about, did you do the job?
Okay.
Is there the semantics of the job, the operational qualities of the job? Does it actually work on screen and do the right math in the right places and the right functions in the right places? And then on top of that, there's, how were conventions followed? Like you could easily write all that in one line, uglified prose that doesn't follow spacing and line breaking conventions or any sort of naming conventions, but still works. Those are sort of two separate things. But if you are having such a hard time because they didn't follow the conventions to such an extent that it's hard to even parse and understand what they're doing, then you definitely want to mention that. That would be far from a messy solution, can be messy to the extent that it sort of messes with your ability to review. And if it does that, then you definitely want to mention it at the top.
It could always be the opposite situation where that's beautiful code, but it doesn't do what was actually part of the assignment.
Yes, pop code. Beautiful and vapid. Like leak code? Yeah. Well, then, and that's the case, then they would just not get perfect scores, right? They would have really good reviews for code style, but if they didn't do it, they didn't do it. Yeah, it would be not perfect, and you'd have a lot to say about how they fell short and why. Yes?
For exercise 2, for the position, follow, and the target focus, when it says distance, does that mean Euclidean distance, or does it mean X and Y?
Euclidean distance.
Okay,
so you can use the vector to distance function.
For position follow, I was having a little bit of a problem using Euclidean distance because it kind of locks certain places and it looks like I don't know, it's kind of hard to explain. When you're going left, it'll follow you, but then when you start moving down, it'll lock into certain angles because it's a circle, right?
Yeah.
A radius. So then it's not smoothly moving around. And also in the example you went over in class last time, that person also implemented the X and Y separately. So X could go least distance and Y could go distance rather than just
Yeah, so you would want to use the Euclidean space. You kind of want it to be a circle, and that is one solution. So the circle bounding is sort of a loose thing. Normally, so the other solution to this would have more of a physics-based bounding, where the least distance wouldn't be directly specified. It would basically be a function of the further you get away, the faster the camera catches up. So until they were, the distance, this is sort of a proxy for that. So when you are starting to move at maximum distance for long enough, you will get a static state between you and the camera. As long as you keep going, you slow down, the camera will eventually catch up. That's sort of the proxy what we're going for. I don't know exactly what you mean. You have to show me about it being stuck in angles. Are you testing with a controller, or are you testing with keyboard and mouse?
keyboard and mouse.
Okay, so it's likely that your angles are, I want to disambiguate whether it's caused by the actual leash distance logic or caused by you only being able to move in 8 directions. So if you test it on thumbstick, it could be different. I'm just curious. We'll have to maybe do that in office hours or something.
Yeah.
Any other questions? I saw a lot of work. There were a lot of questions at 4 a.m. on Discord last night. I was answering questions at 2, and I was looking at questions at 6. It was definitely the sweat equity is now being poured in. Are y'all enjoying the assignment? Maybe it'll be better when you're done. Yeah, they're hard, but it's also you'll learn how to make your own cameras now. Exercise 3 is a little different in kind and feel. So hopefully, if you did like exercise 2 and it's open-ended nature, exercise 3 is a lot more formulaic. There are canonical correct answers, unlike the exercise 2, which has solution spaces. And the Pikmin are a little cuter than terraforming capsules. So hopefully you'll enjoy playing with that a little bit. All right, peer reviews are due at 11:59. We'll start pulling those repos right away and get a cut and start grading. I guess Kyle, let me know when you start pulling and go. I'll tell people to, now we'll have to do a freeze. Or if people make changes past that time, we'll have to know and take that into account when we grade. All right. Any more questions? We're good? The recordings are up. I post them right after class. I'm trying to post them right away when I can. Hopefully the audio balancing is better. I took a hard look at that, and so hopefully we want to report or re-record or re-describe something we've already done in discussion. We can let it be. Yes?
Well, when looking at the player control for this, it seems like, if I'm understanding correctly, it does kind of have like a max x and like max x speed, max y speed, because it's like just fetching the inputs and then multiplying that by like the player speed. And
Yeah. Go ahead.
I think that to a certain extent, like for me, it caused me a lot of confusion with how to deal with the actual like diagonals for player.
Yeah.
Because so like if I understand correctly, like it moves like this way, but actually like moves a bit faster on diagonals because of the X and Y. Okay.
Anybody else want to expand on this? Anybody else see this? Yeah.
Yeah, because like the x and y would be 1, and then 2 1s that do something is not like
Yeah. This is the case. Anybody else want to have more to say? Anybody else want participation codes for saying more? This is actually one of the hidden things in this project that I always wait for people to find. This is an unnormalized diagonal movement. This is a classic game design bug. You have the codes? All right, we've got a couple here to give out.
The reason why I was thinking, since like he was mentioning how design was stage 3, and the fact that the code worked like that gave me a lot of problems with stage 3, because I kept trying to.
Yeah, this is the meta of why I asked, do you have any more information about why these angles happen? This is exactly like one of these like teachable moments placed in into these assignments. So intentionally, we weren't correcting for the bonus movement you would get by being able to move full X and full Y simultaneously. Notice we did not find the movement direction, normalize it, then take it times speed. Right, like I've told you to do inside the assignment descriptions. I was waiting for people to correct this. So what's a good way to show this? The webcam isn't really good. Maybe I'll do a bit of this and post it on Discord. But basically, this is a problem in classic games, and you'll see this in speed runs a lot, where early games did not correct for this diagonal motion, so you actually can move faster throughout the world by moving always in diagonals because you're moving max X and max Y simultaneously, instead of a normal movement speed. A good example of this is the NES game Crystallis. This is very, in NES, Sega, Game Boy era, this was a problem. Do you have another example? Yeah. The original Doom. Oh, yeah, Doom. So Doom did that as well? What? Carmack didn't correct for diagonals? Okay, we'll do fast 1 over square root of x, but we won't correct for diagonals. That's hilarious. Yeah, thank you. Does anyone else know of any other games that do this? Yeah?
Uncharted is one of them.
Which one?
Uncharted.
Oh, Uncharted?
Uncharted. It's like this.
Uncharted?
It's this really bad survival game.
Oh, okay. I just haven't played it. I don't know about it. Okay, yeah. So this is something GameFook's been doing for a while and correct for, but it's one of these like gameplay programming things that may not be intuitive until you actually start doing the math. And I love when people self-discover this. This is like one of the fun lights I like to see switch on in people's head, because once they understand that, I know they have an understanding of like the basic ramifications of vector math when applied to movement and translation. It's like one of those unlocks. All right, we'll have to have a sidebar on that, maybe in a discussion section. I want to get some pretty examples for you to show off. And that's much easier to do on my nice machine rather than this laptop. Excellent. Well done. Well done. Any other questions? So yeah, if you get the funky angles, you may want to normalize the movement, the player direction. It's a 1 line of code. Zoom type. All right. Let's look at the LERP example quickly. I'm going to leave time to play. So this is the LERP Playground project in the Gameplay Programming Class Repositories project folder. It's fairly simple. It is a plane, or a main camera, directional light, a big blue plane, a jellyfish, a smooth jellyfish, a smooth damp jellyfish. Oh, thank you. Thank you, thank you. Just because I can see it doesn't mean you can. All right, there we are. That's better. Thank you. Too much to cover. Okay, simple scene. Load sample scene. When you load it up, we have main camera, directional light, a large blue plane, jellyfish, a smooth damp jellyfish, and a curved jellyfish. And these jellyfish are all made of basic Unity objects. So if we go to jellyfish here and we hit F and take a closer look, you can see that it is a sphere that has been scaled, and then a bunch of other spheres which have been stretched to look like tentacles. Very simple object, copied and pasted. The jellyfish has basic, mesh renderers, sphere collider, the basics, and a linear movement script. Smooth jellyfish has a smooth damp movement. There we are. Linear movement, smooth damp movement, and curve movement. So let's take a quick look at this. So one thing you can do is you can hit Shift Enter. It'll maximize whatever Unity window that has focus. Nice capability. This is scene. We actually want game. And I'll hit play. And we'll wait a minute for it to compile. Now you see, we've got a little jellyfish race. We have a super fast jellyfish, and we have some slower ones. Once again, you can see how they move. What can you tell about their movement qualities? How are they moving? Where are they different? How are they different? Yes?
The smooth one is one of the smoother ones, and then the one on the top is very jittery.
Okay. Can you can someone qualify or just more describe what we mean by smooth here? what is smooth in this case? Yes.
As it approaches its target point, it slows down and eases.
Right, so easing in, a sense of acceleration and deceleration, instead of instantaneous velocity that is constant until stop. We have an acceleration ramp, and a speed, and then a deceleration, then a fall. So we'll talk about this, particularly when we talk about game feel later in the course. But if you take your hand, and let's say you have an object. I'm going to use whatever this is. Looks like it is some sort of cleaning cloth. When I take my hand and I reach for it, there's an acceleration first, getting things moving, orienting my hand, and then I move quickly, and then when I get close, I slow down and have fine-tuned movement. Right? This is an organic motion curve. A small ease in, a lot of speed, and then an ease out for fine-grained movement. So when we see this, it looks much more natural, lifelike. This easing in, this easing out. There are lots of ease in and easing out functions. We'll have an entire lecture on these one-dimensional transformation functions, perhaps at the end of next week, maybe the week after. We'll go pretty deep into this, and there's a really interesting, I found pretty inspirational GDC video about how to design and handle these 1D transformations that we use for movement or tweening or moving motion in between frames or linear interpolation. All of these are very related concepts and all used together for this ball of motion programming that we use for things like acceleration curves. Or there's a lot of really interesting curves baked into the Jump and Smash Brothers characters. Mario has a classic set. We'll go pretty deep into these. So, looking at this, let's look at the linear movement script. So this is a script that's driving the jellyfish, not the smooth damp, not the curve, but the jellyfish. It's a fairly simple class. Here, we have called linear movement. We have start position, end position. We have this vector 3, the direction of movement, how far we want to go, and we have a duration. So here, we find our start position, we record it, and we set our end position to be start position plus movement. So this movement really is the offset of where we want to end up from where we are now. It's a relative vector, a displacement vector. Now, the update here, we want to see how far from our start point to our end point we've traveled. So we know we want to travel this vector, so we want to travel -10 on the x over 5 seconds. So if we've traveled 2.5 seconds, how much of that vector should we have traveled? Assuming linear interpolation, yes.
You said 2.5 seconds.
Yep,
So would it be like -5?
-5, right? If we go from 0, assuming that 0, 0, 0 is our local origin for our object, and we want to move 10, 10 in 5 seconds, 2.5 seconds, we should be right in the middle at -5 from the original spot, I guess. -5. I'll mirror image it for you. Right, so that's basic normalization, basic interpolation. You've done this a million times in math classes, I bet. It's a mapping of a 0 to 1 value to a larger, different number space. Right, in this case, it's a linear mapping. And so what we're doing here is we're looking at the movement times time.delta time times this duration, right? So we're seeing how much, what small fraction of that movement should we do this turn. That's distance covered. And so we have our fraction of a journey. We can look to see how much of our journey we've covered. We can look at our start position. We can look at our transform dot position plus distance covered, and we can see how much we've progressed already. And then we can update our position with these values. Our fraction of this journey times, we can LERP. So here's where we're actually using vector-based linear interpolation, like you've probably seen in the documentation. We have start location, end location, and 0 to 1 value of where you are between those two in a standard linear way. No curving, no easing in, no easing out. Yes?
You scroll to the right. I don't think we should encourage
Yeah, sure. You're right, I did not. Let's see, view, let me turn on word wrap. There. So we have our start position, this is transform.distance covered, so this is how much we've covered so far, and this is how much we should cover in total. Right, it's a fraction, a ratio of start to finish, how close we are, where start is 0, end is 1, where are we in there? That's the basic of how linear interpolation works, right? You crank up, you take that number from 0 to 1, you can move around and you know exactly what position you should be in based on the 0 to 1 value. I guess I'm assuming that this sort of thing is taught in algebra, pre-algebra, a bit in calculus and linear algebra as far as vectors go. Do you all have done these linear interpolations before? Yeah, you have a question?
Yeah, why we said the distance covered as a variable?
Do what?
Why we said the distance covered as a variable? I mean the type of.
Oh, var?
Yeah.
So that's also part of convention. If you look in the best practices part of the code review, code style guidelines, you want to use var when the data structure, the data type is obvious. And in this case, it's all float values. Yeah. That is sort of C# convention at this point. Good question. Right, so there's a bit of math in here that I didn't have to do. This is sort of explanatory. These are all the points that when you deal with linear interpolations, you'll do fraction of journey. You may care about distance covered. You may care about using vector3.lerp. Basically, we're kind of recreating the math in LERP several times throughout here, but this is, I want to give you a few different perspectives on how this function works, and so that's why there's more than one line of code here. All right, so that's linear movement. Let's look at smooth movement. So this one's, we're after the explanatory LERP basic version where we expose a little bit more of the inner mechanics, we're going to walk right in to using LERP in a much more standard way. So here, very much the same thing. We have a goal of where we want to get to. We have a duration on how long it should take to get there. We want to mark our start time, start positions, and end positions, so we know where our borders and boundaries are. And then the update function. We're changing our position, we're updating it to be LERP. Let me also turn on, I will not accidentally try to use Mac key presses instead of Windows this time. Toggle word wrap. Oh, that didn't work very well. Okay, let's just do something a little bad here and we'll pull out each one of the arguments separately. Okay. There. Is that legible for everyone in the back? All right, so we have vector3 LERP, we have the start position, we have the end position, right? I guess I can do this. And then we have math smooth step, which then takes these parameters. So math smooth step maps a value of 0, 1 to an ease out, ease in space. So smooth step is just like we described as smooth motion earlier, right? You start off slow and you accelerate, and then you end up decelerating. So the graph, I'm sorry for those of you watching this and recording later, this is in the documentation for smooth step. We have a value over time. This is our 0, this is our 1 in time. This is our 0, this is our 1 in position. Smooth step takes, doesn't change the position very quickly, and then ramps up, and once it gets towards the end, it curves off. Kind of looks like an S function with a tinier curve on each side. Right, so you would be up to 1 up here, 1 and 1, and 0 would be a 0. A faster acceleration in the middle, slower acceleration at the end. Smooth in, smooth out. Ease in, ease out. So the smooth step does that. So it's like, hey, give me a smooth step from 0 to 1 times this start time, this duration. So once you, let's say you give it a 0.5 in time, it'll maybe give you back a 0.3 in distance. And once you give it like a 0.95 in time, it may give you back a 0.99 in distance, right? So it's not a one-to-one mapping between time and distance, which is what we're trying to achieve here, nonlinear mapping. Now, once we have that mapping of 0 to 1 in linear to 0 to 1 in smooth space, in smooth transformation, we can then apply it to the in-between space between start position and end position. Right. Does this make sense to you? This smooth step being embedded in that 0 to 1 normalization value in linear interpolation? Some people are nodding. Some people look a little confused. Are you confused? Let me know. Are you good with this? Okay, I'm sure. All of you have many engineering classes at this point. Yes.
Can you explain the last one about smooth step?
Of smooth step? Yeah. So we're taking our current time minus the start time. So how long have we been doing this? So notice we tagged the start time when we started the interpolation process. We tagged that on start. So we know the time step of when we started. So if we take the time step of when we started minus the start time, we get the difference, right? So time will keep increasing, start time will stay the same, so we'll get a positive value here, which is how much time has passed since start time. And then we would divide that by the duration, or how long we should be doing the curve, right? So when we hit 5 seconds, we should be at 1. So when time advances 5 seconds past start time, that will be the same as duration. So it would be 5 over 5, which would be 1, which would give our smooth step 1, which would put us all the way at our negative 10. Did that help? Cool. All right, there's smooth movement. Smooth damp is a little different. So here, smooth damp, it has reference values. So reference values, just like in C++, they're input and output variables. So it will take that float and it will change it, and change the reference that you pass to it. So it'll be altered. It'll be side affected by smooth damp. Okay, so we want to take our start position, our end position. We want to pass it the thing we want to update, and then this dot duration is that value from 0 to 1. Where did I set this dot duration? Okay, no, I guess that's 5. Okay, yeah, that's the amount of time it should go. It should do the smooth damping from X to Y, changing this intermediate third value. Start, end, value that changes, how long it should take the change. So this function, it's called once per frame. What am I forgetting about this function right now? X pause, Y pause, velocity. Okay, I'm forgetting something about the intricacies of how this function works. I'll post some information about this. I'm missing something here. Pardon me, I'm just flubbing on the stage. But the effect is, as you see, a smooth damped movement, a even more dampened version of moving. Smooth damp, has a stronger acceleration curve. This one's really slow. That's smooth. Which one is smooth damp? Okay, smooth damp is the third one. Okay, smooth damp. Okay. So maybe this one just has... It looks like I have some logic error in this code. Pardon me, I'll fix this and I'll get back to you the canonical answer. The fun one here is actually the curved jellyfish. This is where you get to draw your own smoothing curve. So notice here, we have this little motion curve. Click on it and edit it yourself. Let's say we want a really procrastinating jellyfish. We can do a curve like this. Can add a little key here. And now that fourth jellyfish will not do a whole lot, but then as time goes on, it'll ramp up a lot, ramp up fast, right? That curve at the end really shot up, right? So that's the distance over time. So look at the curve. Notice how it just skyrockets right at the end, right at 0.9. So it's like 0.85, it's like 40% of the way to 0.4. And then at 0.9, it's like 0.5. But then that last 10 seconds covers almost half the distance. Or the last tenth of the 0 to 1 space covers about half the distance. This is how I worked on assignments as undergrads. Oh gosh, the deadline. All right, so let's take a look at how this works in code. So animation curve movement. What we have here is using a Unity animation curve component. You can plug these just in about any script that you have. You just use it as a variable. Its printout, its serialized version is that little user interface, right? And so what you're doing is you're giving it that curve, and it will help you calculate that curve. If you give it a 0 to 1 value, it'll show you where in this 0 to 1 space you are. So 0, 1, 0.1, 0.2, 0.3, 0.4, it'll tell you how tall, how far up that green line is. You can even make things pretty cartoony. Let's see, let me add another key here. You can make it do this. It'll have a wind up before it shoots off. So it'll go backwards a little bit and then start lurching forward. Then we could potentially even, let's see if the implementation will support this. Smooth jellyfish, go to the curve, we'll have it bounce in another direction. Top jellyfish. Oh, looks like we may be clamping the values. Yeah, okay, so it's not going past the line. There it is. So if you did your own interpolation math, you could see when that value goes under 0 or over 1, you could have it move just past the target on either side. So it'd have like stop and a lurch back, right? Very very cartoonish movement. Very expressive movement. All right, so we have this animation curve component, and it's pretty easy to use. Basically, you give it a value from 0 to 1. So what we're doing is we're taking our time the animation started, or taking the current time minus when the animation started to get that time difference. The time has elapsed since start, dividing it by the duration so we know what fraction of 5 seconds we've traversed so far. We pass that 0 to 1 value into motion curve.evaluate, and that is the x-axis. It will show you where that green line corresponds to that on the y-axis, on the what y value that x value will give you. And so that's how you can design one-dimensional curves and algorithms to do anything from tweening to damage value of your flamethrower over time as it ignites and starts shooting out more flames. You can have it correspond to a shockwave effect and how much like it bounces things around in the world when the shockwave hits them. What sort of x or what sort of y displacement will happen? There's just every use in the world for these one-dimensional curves. All right. I will fix up that the smooth damp. I'm not sure what I did there, but it wasn't good. I'll fix it up for you, make it good, and send out explainer. All right, any questions? Does this help clarify anything on LERP for you? I think I'm more confused now. Sorry about that. You can't win them all. Batted 75 on that one, though. The other two were pretty good. The other three. All right. Retro, I can spell. There we go. Let's play some games. What should we start with, Kyle? I picked a fine assortment. My sommelier of game SNES game selection here. Starting off with this platform. Ooh, okay. Well, yes. I don't think that one warms up fast enough for us. I think there's a lot of early text. Sorry.
Is Chrono Trigger?
I think Chrono Trigger may fall into that same point. I think we need a longer warm up for that.
Alright, then Super Mario World.
Super Mario World. All right, I got my speedrun.net approved emulator. Open volume mixer. Output device, Crestron. That didn't actually go to. Okay, let's try this again. There we go. Oh. What is happening here? It is not showing on my screen. Okay, this just means the thing is too big. Okay, minimize. Thank you. What, you don't want to see my file menu the entire time? Does anyone want to play Super Mario World while we talk? Is anyone a speedrunner of this game? You want to try it? I am in plugged in mode. Alright, so our goal when we play this is you should be looking for gameplay systems and game mechanics and talk about potentially how you would implement them. Yep, come on up.
Very brave.
Yes, very brave. This is one of the things we give out
There you go.
station codes for.
Oh, thank you. I just want to play Mario.
Yeah, just go ahead and just play as you will. Have fun. And we'll talk about it. Okay, so this is a Super Mario Brothers game. What are basic mechanics that are happening here? Jumping, right? It's a platformer game. Yeah, so we kicked shells, they moved around and hit a bunch of enemies. We have these fruit sprites, we have background, we have parallax, we have Koopas coming out of their shells. They wear t-shirts. They're not only in Super Mario Wonder, right? We have a checkpoint, we have pipes, we have question mark blocks, right? So all of these are defining aspects because Mario is so influential. Mold! All right, so let's talk about basic mechanics. Moving left and right. Who can describe what's going on with Mario's translation? Yep. Right, there's an acceleration, there's an ease in, and then there's friction when he stops, there's an ease out. We have an
remap the
overworld.
buttons?
Do what?
Can I remap the buttons?
Yeah, sure.
Right.
You're gonna put like jump on left trigger. You're gonna be like Dark Souls about
Yeah,
your.
yeah. That's exactly what I'm gonna do.
There's a mouse if you want to use it.
Oh, sure.
That touchpad is bad.
I'm forgetting where 8-bit do or like RetroArch has it.
Yeah, it may be in a context window that pops up down
Oh,
here. Is
okay.
that? I may be confused with the OS X
Yeah, I only
version.
use
OpenEMU.
Sorry, what? I've never used RetroArch on PC.
Yeah. Okay. Let's see. Take screenshot. Windows X1 mode. Okay. So I'm not actually seeing that here. Let's see. Okay, that's just
okay.
that's just speed up.
Maybe it's in the window before.
It must
you have
be.
to exit the game.
Yeah. Let's see. Can we take a snapshot? Do you know?
Yeah, if you go to the menu toggle, F1.
Aha!
Oh, okay.
Thank you. Thank you.
Options. It goes down.
Options. Thank you.
Oh wait, no. There's a dedicated controls.
Oh,
Gotcha. Gotcha. Back. I got you. Yeah. Controls.
you should have just.
Audio interpolation, emulator hacks again. Okay, I didn't see it. I probably went to the wrong one again.
Oh, would you like to continue the conversation and I'll change it?
Yeah, sure. Sounds good. I'll let you all handle this. Get a little hands-on, So there's ease in and ease out in movement. So what about relative speed? Is Mario moving like a human? No, Mario's not moving like a human at all. So that's movement in X and Y. What about up and down? Jump. What about Mario and jumping? How is jumping working in this game? First off, is it a facsimile of the real world? No. Why is it not? Describe to me this difference. Why can Mario jump higher than me?
Because he's the
Like literally higher than me. Like yeah, people had hands. Go ahead. If you want to see.
Why isn't like? Why would he do that? Game design? Why would he feel like that?
Yeah, we're right here. We're describing unit mechanics here, so we're just talking about the jump in isolation. But feel free to contextualize.
Well, I know like one thing they do with Mario's jump is longer you hold the jump button, the higher you go.
Yeah, right. So now there's player control in the jump. It's not simply like we do. We once we leave the ground, we are in a set trajectory unless we have like a jump pack or you're on one of those really cool things you do in Florida where you have a water pack that sucks a bunch of water and shoots it out behind you, a water jet pack. Like we don't have that. So Mario already has some superhuman capabilities in that he can change his trajectory magically while in the air. And Mario can decide how high he wants to jump after his feet have already left the ground. Right? The longer you hold the button, the higher Mario jumps. If you tap it, he'll do a minimum jump, a hop. The hop is already more than his height, I believe, particularly when he's small Mario. So we already have like this notion of a difference in the real world, a stylized notion of running and jumping. Right? Okay, so we've defined one of the mechanics. Now, what are other core mechanics? Where does this running and jumping, this movement, how is it contextualized? What does it interact with? What's the basic thing that Mario interacts with?
Well, throughout this world, there's interspersed with like floating platforms and these large hills that to get on top of. Oftentimes, giving you like good vantage points, especially when enemies are coming, or you need to get to the next part of the level and cross big gaps. And because of for those races, the player is encouraged to make these sort of like going through these platforms, and in order to do that, they need to jump, often very high and very precisely as well.
Right, exactly. So now we have this interaction between two base mechanics. We have this notion of Mario moving, and we have this implicit notion of physics and gravity. So we have Mario on platforms, touching them, moving left and right. We have this design space now, because Mario jumps high, much higher than humans can. Now we have this design space opening up of a bunch of open space. A bunch of thrilling looking jumps, superhuman feats, and falling down to your doom. So this is sort of like how the game is designed and balanced, right? You have to have this rhythm, this jump, this precision of this motion, the stylized Mario motion going through different levels with various degrees of treachery. And then there's also things you can touch and interact with other than the ground. What's going on there? We've talked about Mario moving, Mario jumping. We talked about Mario touching platforms, and we talked about open space and falling to doom. What else is there? Am I going to be able to use this controller when you're done?
Yeah,
or is it remapped to something
no,
that I will not be able to understand later?
I think I accidentally unmapped my face buttons, so
Oh,
I
no.
currently cannot run.
Is there a return to default that I can use when you're done?
Yeah, but I got lost in the menus. UI?
Yeah, RetroArch.
Sir?
I usually play on OpenEMU, or I just like run
Yeah.
like SNS 9X directly.
Yep.
This was just a simple way for me to run a bunch of different emulators for class at the same time. So, continuing our conversation, what else is there? What else does Mario interact with? Yes? Jump on enemies. So we've talked about jump. Now this enemies is new. Yeah? Coins. So we have these coins you pick up for points. Yeah, once you get like 100 coins, you get a life. Was that the same? Was that still in Mario, Super Mario World? That's in the original Mario. Yeah. Yeah, so this is a more complicated thing. This is the second order effect, right? You have enemies, but then you also have things that can come off enemies that can become interactable, that become more neutral objects. Classic case, the green shell. And there are different colors of shells in the game that have different effects, particularly when paired with Yoshi, which we haven't seen yet. What else? Yeah?
Sort of like a health system where when you get damage, you become like smaller to like
Yeah, there's a power up and health system. There are power ups you can interact with. Normal, like small Mario dots when he gets hit by anything. Mario that's bigger shrinks down to small. If Mario has a special power like the magic cape, or any number of other suits. Big bullet. There we go. The mushroom. Pick it up. Big Mario. Big Mario can take damage. You don't have to. Big Mario also can do this larger spin jump and does extra destructive damage when he hits something's hit. Also can destroy blocks a little more readily when he jumps up into them with the spin jump, if I remember correctly. It's been a while since I played Super Mario World. Right, so we have this power-up set, which gives you more capabilities, plus gives you more safety. There we go. Crunch the block. Normally you'd just be able to jump on top of those with small Mario. What did we do there? What happened? We went down a pipe. Classic Mario level traversal. We have checkpoints within levels. So if you die, you'll come back here. Yes.
The thing I'm noticing too is some levels will level you out based off of the ground you land on, and some of them won't, depending on like the level design. So you actually have to get the
Yeah. The control scheme from the camera controller to the actual player controls can change depending on which level you go into. Absolutely. Water levels are a classic example of this. Oh no. All right, so we have these various enemies. So what happens? We have these enemies set at different trigger points. They're designed to be at specific places in the level. Right? They're designed that way to give you obstacles, to give you a little puzzle to solve, to give you challenges, to provide interest and fun gameplay. So this is where we're going from mechanics and using them in unison to design levels and play experiences. We also, starting in Super Mario World, no, I guess Super Mario 3 started this, an overworld map where you can have some sort of way of going between this basically graph that opens up further when you defeat levels. So you can traverse the world. The more stages you complete, the more of the world unlocks. Yeah.
The map also opens up more options to the player as they can go in different directions and potentially like explore other levels directly.
Yeah, you open up more nodes in scrap space. Yeah.
Which was not something you had, for example, in the original Mario, where it's just like a linear trajectory. Except for maybe like, going to secret levels within levels, but
Yeah.
it was more limited.
Now we turned the emulator on to 10x. This is the speed of speedruns. Giving up on the controller entirely.
It wasn't the best idea.
All right. Let's take a look at another game now and do some comparison. Right. So we kind of have a handle on how move and jump works. Thank you for helping out. Let's compare that to another game we can get up and running quickly. Now, is the controller... let's see, we had...
Yeah, I tried and apparently it's not the controller was
Oh, interesting.
So maybe the controller was actually keep moves.
Yeah, it might be. Input, maximum user's polling behavior, touch safe. MIDI controls, feedback, port 1, this is port 2. Device index. There, we'll do this one. Okay. Let's try another quick one. Let's do UN Squadron. Probably a game you may not have heard of. Oh, but still, yeah, thank you. When you're dealing with multiple monitors, Windows does some pretty funny things with the size of your windows here. So this was based off a manga. Shin Kazama, let's do it. So this has an overworld objectives you can do, but it is mostly shmup plus a store. So I'm gonna take this level 1 plane, the Crusader. Let's get some bombs. Right, so it's got some standard shoot 'em up techniques. So what's going on here? What mechanics do we have? Kyle, can you moderate a little discussion while I play?
Sure.
Can you lead through gameplay discussion, or do you want to play?
Not one.
Whatever you feel like.
Another student play.
Yeah. Does anyone else? Does anyone want to play UN Squadron? Yeah.
I'm stuck at this so hard.
That's okay.
Yeah, let's go. How do I unpause?
Start.
Got it.
For the
Wait,
extremely
frick.
brave.
Oh, fuck.
So you got the bombs.
Trust me, that suicide
Alright,
attack
so we
was
have-
tactical.
X is the
Yeah.
center gun. B is bombs.
Okay, got it. Yeah, same
When
thing.
B is select. Yeah, there you go.
Interesting.
So you have cash you can spend. You actually gain some cash from that
like-
level from the pickups and blowing things up.
I see. Pretty interesting. Okay.
And so if you hold it down, it'll fire for a while, but there's a cooldown on how long it'll auto fire. It's one of the things you can upgrade through the game.
Oh, whoa.
You're gonna get tanked. There you go.
Oh my god, they're taken from behind. That's pretty interesting, and I can't go backwards, so.
Right, so this is a pretty interesting, difficult shmup, right? So what are the basic game mechanics that are going on here? In 2 minutes.
We have
Yeah.
aerial bombardment.
Yeah, right, so what
Oh,
type of
wait.
camera do we have? Auto-scrolling. What variant? How's it
Wait.
working?
Ah!
Do you think you could push it forward? Or up and down?
Yeah, okay, let's go. No,
Nope.
nope. Hey, look, it was a worthy sacrifice.
Okay, and so we have bullets, shooting, movement, enemies, the basic things you have in shoot 'em up games.
Okay, I'm gonna go some thermal.
So in Unity, what would each one of these? How would you make the ship? What basic Unity objects would be
Oh, whoa.
constructed? Oh, you use the cluster. You only have 2 left.
Oh, I'm wasting military resources. Oh my god.
Yeah.
Well, you just have basic game on it and push it around with controls. Because there's not like momentum when you just let it run.
Right, so it'd be like translation, just
Oh.
like exercise 2. So you probably need a script to handle
Oh,
movement, right? So the implicit things
What-
are buttons are being pressed, and the simulation, the game world is reacting to those pressed buttons.
Why did you use it?
Bro.
I used it?
Oh. That.
Danger, danger! So notice that you could take more than one hit. There's this life system. So there are 2 phases to it. You get hit, there's a life bar, the life bar goes down, then you're flashing, you're in danger. If you get hit again while you're in danger, you die. But you can recover after a period of time, and then go down until you go into danger and recovery periods until that bar is all the way down, you're in danger permanently until you die. And it's 3 o'clock. We'll
Okay.
continue on to some more UN Squadron. I kind of want to finish discussion on this one. So I think
wait
it's
a
a pretty
minute.
interesting game. And we will talk about bullets, bullet mechanics, pickups, power-ups, bombs.
Let's go.
We'll try to more fully describe the Unity
Let's end
implementation
this.
or a high-level sketch of how to implement UN Squadron. Have a great day.
I have a quick question. Does Terra